Hello everyone. Thank you for joining in the week 10 of this problem solving session. I'll wait for a while so that other people can join and then we'll start this session for today. So now I think we can start and today's session is mainly on the shear strength of unsaturated soil. This course is on unsaturated soil mechanics and this course is instructed by Professor T.V. Bharat from Department of Soil Engineering IIT Guwahati. And my name is Satyam Tiwari. I'm a PMRF TA for this particular course. So before we start the session for today, we'll start by solving one of the problem we discussed in the last session, and because it will provide us a base for solving the problems in this session. So this is one of the problems we have been discussing, and here a sandy soil is provided, and nine number of tests are conducted on this soil. First test is conducted on the UA minus UW. Let me get the pen. So first test is conducted on UA minus UW or a matrix suction of 0. The second test and so on are conducted at different metric sections. So here the major principal stress sigma 1 minus UA is provided, sigma 3 minus UA is provided. What we need to calculate here is the or the effective stress parameter. So for calculating the effective stress parameter, we can use this relation we have in the theory class you might have been derived. And in this expression, you will see that in the numerator we have sigma 1 minus UA minus sigma 3 minus UA multiplied tan square 45 plus pi dash by 2 minus twice c dash tan 45 plus pi by 2 upon the denominator part includes 2 times UA minus UW matrix suction tan phi dash tan 45 plus phi dash by 2. So here we have everything except phi dash. So how we can determine the internal angle of friction? We will use the first expression where the matrix section is 0 so as to determine the phi or the angle of friction. Okay. And we'll assume that this angle of friction remains constant for all other values. So if we look at the Mohr circle, and this axis is let's say sigma minus UA and this axis is tau. And the intercept here will be let's say C dash. Okay. This will be nothing but C dash cot phi dash. Right? If this is phi dash. Then if we draw a line from the tangent point to the center of the circle, so this point will be nothing but sigma 1 minus UA. This point will be nothing but sigma 3 minus UA. So how if we if we need to write the expression from sine phi dash, then how we can write? Sine phi dash will be equal to, so sine phi dash will be nothing, this angle will be 90 degrees, okay? So it will be nothing but this, if this triangle is ABC, then it will be nothing but BC divided by AB, right? So how we can write BC? BC will be sigma 1 minus UA minus sigma 3 minus UA divided by 2. Okay, the radius of the circle. And then AB will be the distance from O to B, sigma 1 minus UA plus sigma 3 minus UA. That will be divided by 2. That will be the average length or the length OB. Okay, plus C dash cot phi dash. So here, as the soil is provided as sandy soil, so C dash will be 0. So if we put 0 here, then this term will become 0, right? Okay, so this term will become 0. And if we put other values for the first one, sigma 1 minus UA is 180 minus sigma 3 minus 2 and 2 will cancel out. Sigma 3 minus UA is nothing but 50 upon 180 plus 50. So if we determine the value of phi dash, then it will be sine inverse and this value 180 minus 50, 130 divided by 230, right? So let's calculate this value. So it will become sine inverse of 130 divided by 230, and it will be nothing but 34.417, 34.417 degrees. Okay, so now we have the value of phi dash, and we need to calculate the value of xi for each test. Okay, so let's say how we can find, and to find it out, we will first put the value of xi for the first test. For the first test, as we know, this test is performed at the saturation, and the maximum value of ZIF at saturation maximum value of ZIF will be 1, because the value of effective stress parameter varies from 0 to 1, and this value 1 is at saturation. So for the first test, we can write the value of ZIF as 1, right? For the second test, we'll calculate the ZIF. So for the second test, sigma 1 minus UA failure minus sigma 3 minus UA at failure, tan square 45 plus pi dash by 2, and the term containing C dash will vanish. In the denominator, we'll have 2 times suction value into tan phi dash, tan 45 plus pi by 2, right? So for the second test, we will have sigma 1 minus UA as 200, sigma 3 minus UA as 50. Then we'll have tan square 45 plus phi dash by 2. So 45 plus 34.417 divided by 2. In the denominator, we will have 2 times suction value is 10 into tan 34.417 multiplied by tan 45 plus 34.417 upon 2. So the XIF value we can calculate 200 minus 50 into tan inverse, oh, sorry, tan, this is going to be 45 plus pi is 34.417 divided by 2. And we put a square. In the denominator, we will get 20.002. This will be divided by 2 into 10 into tan 34.417 multiplied by tan 45 plus 34.417 divided by 2. So it will be 25.999. So the value of XIF will become 20.002, which will be divided by 25.999. So it will be around 0.77, right? So let's take a eraser and we'll erase some of the values which are written here. So as we can write the value of XIF. Okay. So here we will write the value of XIF. So for the first one, it is 1. For the second one, we have calculated 0.77, right? Now for the third test, we will also calculate it. So XIF will be equal to sigma 1 minus UA value is 220 minus sigma 3 minus UA is 50 into tan square 45 plus 34.417 divided by 2 upon 2 times U minus UW is 25 into tan of 34.417 into tan square 45, sorry, tan 45 plus 34.417 divided by 2. So now we'll calculate this one also. So 220 minus 50 into tan 45 plus 34.417 divided by 2. So it will come 40.002, which can be divided by 2 into 25 into tan of 34.417 into tan of 45 plus 34.417 divided by 2. So that will be 64.99. So if we calculate, that will become 0.615. So for the third term, the value will become 0.615. Similarly, if you will calculate for the other terms, which I've already calculated, that will be 0.385, 0.231, then we'll have 0.135, then we will have 0.0818, then we'll have 0.077, and going further, we'll have 0.062. Okay, so these value will get. So here we can observe that as the value of UA minus UW is increasing, the value of XIF is decreasing. Okay, so if right, so this observation can be made from here, and in this way we can obtain the value of this vector parameter. So please have a look at this question and do let me know if you people have any doubt in this one. Okay, so going forward, we'll see that we have previously studied the value of the expression for tau f given by Bishop is C dash plus sigma minus UAF tan phi dash plus xi f times suction value tan phi dash. And this one is given by Bishops. And then we have expression given by Fredland. Tau f is equal to C dash plus sigma minus UA times F tan phi dash plus UA minus UW into tan phi B. Fredland. Fine. So from these two expressions, we can observe that this value of phi b, which we can write from these two expressions that tan phi b is nothing but xi f times tan phi dash. Fine. So here one observation which have been given by several researchers that as the value of matrix suction increases, that is GO minus UW, the value of this shear strength increases. And with this, if we observe the value of phi b, as we have seen in the last example, we have assumed that phi dash will remain constant for all the test. Okay. So, but the value of xi f which is there, that is varying, which means the phi, if the phi dash is assumed as constant, the value of xi f is varying. That's why the value of phi b will be varying. So, several researchers have concluded that the value of phi b actually it decreases as the value of matrix suction increases. So we can see from this curve, the value of phi b is more here, then it will decrease and it will reach equilibrium value here. That will equal to zero. Okay. So we will study this phenomena. We'll solve an example based on this. So just like the previous example, we will be solving one more example, but here we'll be also calculating the value of phi b. Okay. So in this example, we can see from the last one, the value for first test results are 0, 180, and 150. So here also, the value of first test results are the same. Okay, let me check. The other values are also same, I think. 100, 240, 50. Okay, fine. So, so this is similar to the last problem. Here we have calculated the value of xi f, right? Value of xi f we have already calculated, and further we have also calculated the value of phi dash, which was equal to 34.41 degrees, and now we aim to calculate the value of phi b for all the metric suction values. So how we can do that is by using these two expressions of Fredland and Bishops. From here, if we will see, then tan phi b is actually equal to xi f times tan phi dash. That is true, and if we calculate this, then we will find phi b is equal to tan inverse xi f times tan phi dash. So let's calculate it for all the test results. So for the first one, we will get tan inverse xi f is 1 tan 34.41 degrees. So that will be nothing but 34.41 degrees, right? Tan inverse tan of 34.41. Okay, so we can write 34.41 degrees. So here phi b will be equal to phi dash. Now for the second one, we can write, this one is for first one. For the second one, we can write tan inverse 0.878 tan 34.41 degrees. So let's solve this. It will be tan inverse 0.878 multiplied tan 34.41 degrees. So it will give us 31.02 degrees. So Here we will get 31.02 degrees. Similarly, for the other factors also we can calculate it. So let's say for the third one, if we calculate, okay, so we can make use of the Excel program for solving this one. Okay, so let's do that in the Excel so that we can also determine the pattern which is provided here. So let me just quickly switch to Excel. Here I have to plot the values of okay. So here we can determine the values of effective stress parameter. Then we can determine the values of phi b, right? So let's insert the symbol phi. So we'll determine the values of phi b here. Okay. So for that we will put the values of C dash. C dash is 0 kPa and the values of phi dash. Phi dash is nothing but 34.41 we have determined. And the effective stress parameters also, which we have calculated, that we'll put here. That is nothing but 1. Then we have 0.878. Then we have 0.665, 0.41, 0.244, and we have 0.142. Next one 0.086, 0.080, 0.064, right? So if we need to determine the value of phi b, how we can do that? We can determine the value of phi b by writing, just give me a second. So we can write the value of phi b as, so we were discussing that how we can determine the value of phi b is equal, then we'll calculate here as we'll define the tan inverse that will be equal to A tan, and then inside tan inverse we will have xi f, that is nothing but this value that will be multiplied by tan of this number which is there, the phi dash. Okay, so phi dash we will put in nothing but the radians. Okay, so we'll multiply it by pi, we'll divide it by 180. Now we can close this one, and this whole value we want in degrees, so we'll multiply by 180 divided by 5. Okay, let's see. So here it comes as 34.41 degrees itself. And then we can copy these values to here. Okay, so here what we need to do is that we have this I3 value which we need to fix. So we'll press F4 and now can do it for all the values. So as you'll see here, the So as you see here, the value of phi b keeps on decreasing as the value of this metric section increases, and also as the value of effective stress parameter decreases. Okay, so here we can plot also. First, we will plot this metric section versus effective stress parameter. So we'll go here, insert, and we'll plot with the line plot. So as the metric section is increasing, the effective stress parameter is decreasing. Then in the same plot or in a separate plot, we will plot metric section versus the phi b value. Let's insert, plot, and the line plot. So this phi b value is also decreasing as the metric section is increasing. Okay, so xi f and phi b are following the same trend because they are they are correlated with each other, right? So let's switch to our slide. Okay, here. So here we have observed that as the value of matrix section increases, the value of xi f effective stress parameter decreases, as well as the value of phi b also decreases. Okay. So to taking care of this non-linearity in the value of phi b, several methods have been proposed, and three methods which are proposed here are considering two-line zone, or the first line in the first zone and the second line in the second zone, and then calculating two phi b values. Then the second one is by considering phi b throughout. Okay, so that is a more conservative approach. And the third one is piecewise linear approach, where we calculate the phi b for all the piecewise values, and at every in this intersection, we will calculate the value of phi b. Okay, so for doing this, we will solve it. We'll solve a numerical problem again. Okay, so here test results from 12 tests are provided, and the value of sigma a minus u sigma minus ua tau f and the section values are provided here. And first we'll calculate the value of c dash and phi dash for every test, and then we'll calculate the value of now c1 dash as well as phi b. Okay, so how we can do that? We will divide this test based on the ua minus uw value. So for the first one, we will write A type of test. These are B, these are C, and so on. Yeah, right. So let's solve it for number one test when when UA minus UW is 10. So for that, if we'll solve, we will make use of the equation tau f is equal to C1 dash plus sigma minus UA at failure tan phi dash. So we can make two equations from the test 1 and 2. So what will be those equations? Those will be 130 minus 130 is equals to C1 dash, which is unknown, plus sigma minus UA is 100 tan phi dash, which is unknown. So this will be equation 1. Then the second equation will be 350 is equal to C1 dash plus this will be 300 tan phi dash. This will be 2. So if we solve these two equations, then we'll write equation 2 minus 1. Equation 2 minus 1. Then what will happen is C1 dash term will cancel out. So we can write it here that 350 minus 130, that will be equal to 220. It is equal to 200 and phi dash. So from here, if we calculate the value of phi dash, So the value of phi dash we can obtain, that will be equal to phi dash. Phi dash will be equal to tan inverse 220 upon 200. So that will come out to be 47.73 degrees. So if we calculate C1 dash, then we will get 130 minus 100 times tan of 47.73, which will be equal to 19.98, right? So first set of phi dash and c dash we have determined. So write it here. C dash is 19.98 and phi dash is 47.73. It will be same for both. Then we'll go to the second set of equations and we'll write ui minus uw is equal to 50. Then for that, if we solve, then the first equation will be 520 is equal to C1 dash plus 100 times tan phi dash. Second one is 695 is equal to C1 dash plus 300 times tan phi dash. Solving these two, we will get phi dash will be equal to tan inverse 695 minus 520 upon 200. So it will be equal to 695 minus 520 divided by 200, and tan inverse of answer 41.18 degrees, and C dash C1 dash will be, let's call it C1 dash. So it will be 41.18 degrees and the C1 dash will be, let's calculate from one of the equations. So it will be 520 minus 100 times tan of 41.18. Okay, so it's coming 432.52, so it's too high. Maybe some error in the values are given, so it's a hypothetical data. Okay, so let's move forward. For UA minus UW is equal to 100. So for that one, we will get two equations. 150 is equal to C1 dash plus 100 times tan phi dash, and 370 is equal to C1 dash plus 100 times tan phi dash, sorry, 300 times tan phi dash. Then we'll calculate from these two. So we'll get phi dash is equal to tan inverse 370 minus 150 upon 200. So it will be tan inverse 370 minus 150 divided by 200. It will come 47.73 degrees again. So 47.73 degrees. And the value of C dash, if we'll calculate, then we will obtain C1 dash is equal to 150 minus 100 times tan of 47.73. So it will be 39.98. 39.98. Calculating further, we will erase the values for first few observations. Okay, so for UA minus UW values of 200 we'll calculate. So we'll get phi dash is equal to tan inverse Phi dash is equal to tan inverse 720 minus 550 divided by 200. So it will be equal to 750 minus 550 divided by 200. So that will be equal to 45 degrees. So here we'll get 45 degrees and the value of C1 dash will be equal to 550 minus 100 times tan 45 is 450. So we can write 450 here. And for the next one, UA minus UW is equal to 300. We will get phi dash is equal to tan inverse 420 minus 185 upon 300. Tan inverse 420 minus 185 upon 300. So we'll obtain 38.07. So this is 38.07 degrees. And here we'll get C1 dash as 185 minus 100 times tan of 38.07. It will be 106.67. Kindly cross check if I'm wrong at some point. Then we'll calculate for the last one. UA minus UW is nothing but 400. So for that we will get phi dash is equal to tan inverse 790 minus 610 upon 400. That will be equal to 790 minus 610 upon 400. That will equal to 24.27 degrees. So it will come 24.27 degrees, and the C1 dash will be equal to 610 minus 100 times tan of 24.27. So it will be 564.91. 64.91, right? So I'll just erase the calculation part so that we can get more space to solve the question. Okay, so till now what we have calculated? We have calculated that for a particular test number or the value A, B, C, D, E, and F, the pore suction value was U minus UW, F was provided as 10, 50, 100, 200, 300, and 400. For this particular value, we have calculated the value of C1 dash and the pi dash, right? So the value of C1 dash is the one we will be using. So that comes 19.98, 432.52, then 39.98, then we have 450, then 106.67, and 564.91. Okay. So now we have intercept for each matrix suction value. So if we see on the plot, then for 10, 50, 100 at these points, we have some intercept value, right? We draw a slope here, then we have this intercept value, C dash, C1 dash. Okay. From this C1 dash, we will calculate the value of C dash. So let's say from A and B, if we calculate, then what we'll get? We'll make use of the formula C1 dash is equal to C dash plus UA minus UW tan phi B. So let's write for A and B. Then we will obtain the first equation will be 432.52. Let's see about B is equal to C dash plus 50 times tan phi B. And this is 1. Then the first equation 19.98 is equal to C dash plus 10 times tan phi B. This is equation number 2. Let's solve these two and obtain the value of C dash. So while we solve these two, we'll obtain the value of first, let's see, tan phi B. So phi B value will be coming, and this is 10. So it will be tan inverse 432.52, tan inverse 432.52 minus 19.98 divided by 50 minus 10. 19.98 divided by 50 minus 10 is 40, and it will be equal to 84.46 degrees. So this value is not correct, but the data is hypothetical, so there may be some error in the data. And then we'll calculate the value of C dash. So from equation either 1 or 2, we will obtain the value of C dash as 19.98 minus 10 times tan of 84.46. So it's coming in negative 83.12, all in kPa. Okay. So this one we obtained from A and B. Then similarly we'll obtain from let's say B and C. Okay. And then we'll obtain from C and D, E and D and E, and E and F. Right. So let me do it for one more. Let's say B and C. Okay. So we'll write the equation. The equation will be nothing but 339.98 is equal to C dash plus 100 times tan phi B. The second equation will be 432.92 or 52 is equal to C dash plus 50 times tan phi B. So phi B will be coming as tan inverse of 432.52 minus 39.98, which will be divided by 50 minus 100. So from here we can calculate phi dash, but it's coming something as point minus 0.13, which is not correct. So uh, I think so there's some problem with the data set here. That's why the value of intercept is not constantly increasing, but it is more at some point and less at some point. So the idea of solving this question was to uh, uh, get to know you about the procedure, how we can solve these type of questions. Okay, so let me rewind again. So if we have the data of sigma minus UA and we have the data of tau wave and the data of matrix suction, then we can use the piecewise technique by solving the value of C dash and phi dash for two set of tests which are performed at same matrix suction. Okay. Then from each two set of matrix suction values, we will obtain the value of C dash and phi dash. So this will be like one piece for second piece, third, like that. Okay. And then we can determine the values of C dash and phi B from taking two tests at a time, like this. So from there, we can determine the value of C dash and phi B. So we'll get four values, C1 dash, phi dash, then C from there we will get C dash and phi B. right? So take your time in understanding the procedure, and then we can move forward to the next question. Okay, so let's move forward towards the handling of non-linearity. Okay, this non-linearity in the terms of 5b. Okay, so for that, the other expressions are also provided. Okay, like if one of the expression you will see here, that will be denoting the tau f is equal to c dash plus sigma minus ua tan phi dash, which is same as the Bishop's, plus u minus uw times this bigger theta to power k tan phi dash. So here we have not used like the Fredland engine, we have not used tan phi b, but the tan phi dash only. And the term which is multiplied here is the theta k, bigger theta k. What is theta? Theta is the same as the expression which had been provided from the SWCC data in Fredland engine. Okay, so that is equal to 1 minus ln of 1 minus u minus uw upon cr, ln 1 plus 10 to the power 6 upon cr, and 1 upon ln exponential 1 plus u minus uw upon a to the power n and to the whole power m. Here cr, a, and mn are fitting parameters which are obtained by fitting on this on the SWCC data. So if we see the plot of degree of saturation versus matrix suction, Then we have seen it earlier also that this plot will be gradually decreasing and reaching to a residual value. So here, this point where the it is assumed that the degree of saturation is almost 1 here, and after that degree of saturation drops drastically. So this point is the air entry point where UA minus section is called the boiling point section, bubbling point. Okay, so this is the air entry point. And then we move forward. After this point, it is assumed that this soil comes in a residual state. Okay, so no more water can be drawn, and the matrix section values are much higher here. So in this line, if we plot the shear strength versus U minus UW plot, then we'll obtain the value of phi b. It can be assumed as equal to phi dash only in this region of the linear regime where the saturation is maintained, and apart from that, it is said that phi b is less than phi dash. So the range of phi b is always lesser than or equal to phi dash. Okay, so here it is plotted in normalized water content versus matrix suction data. These data points, one and four, six data points are plotted here, and based on the Friedland and Zing model, a curve is fitted here in this data point, in these data points, by optimizing the value of CR, A, M, and. So here we'll solve a numerical based on this equation which we have studied. So here several number of tests are given. Then the value of matrix section for all the tests are also provided. Matrix section is increasing in this direction. Okay, and the value of bigger theta, which is the normalized water content, that is also provided. It's not in KPA. Okay, and this normalized water content is decreasing in this direction. Okay, and then we need to find the value of tau f. Okay, so tau f will be found out using this equation. For that, the data is provided as C dash is 25 kPa, phi dash is 20 degrees, sigma minus UA is maintained at 100, and the K value is provided as 1, this K value. So the expression of tau f is equal to C dash plus sigma minus UA, which is given as 100, and phi dash is given as 20 degrees, plus UA minus UW, which is changing theta to the power k and phi dash, right? So let's solve it for the first one. Then we'll get C dash value is 25, which is fixed, plus sigma minus UA is nothing but 100, tan phi dash is 20 degrees, okay, plus UA minus UW. UA minus UW is for the first one, U minus UW metric suction is 1 into theta, theta to the power k, theta is given as 1 to the power 1. So here the value of k is provided as 1 into tan of phi dash. The value of phi dash is 20 degrees. So we solve it here and we'll obtain the value of C dash as value of the tau f. Will obtain 25 plus 100 into tan of 20 degrees plus 1 into tan of 20 degrees. So it will come 61.76 kPa. So here we'll write 61.76. Similarly for the second one, if we'll determine, then it will be C dash is again 25, sigma minus UA at failure is nothing but 100 into tan 20 degree, it will remain the same, plus 1 into U minus UW is 2.5 to the power 1 into tan 20 degrees. Solving it, we will get 25 plus 100 times tan 20 plus 2.5 times tan 20, so it will be 62.31. For the third one, we will get 25 plus 100 times tan 20 degrees plus 1 into okay, so here there is a problem. This is not 1, here it is 2.5, and the value of theta is 0.99, right? So the value will remain unaltered. It will be same because 0.99 will be almost equal to 1. So here is going to be 5 multiply 0.998 to the power 1 into tan 20 degrees. Solving it, will be getting 63.21. So we can use the Excel program to solve these problems here. So how we can do that is, let's just do Excel again, and coming here we'll open a new sheet. So written, we'll write all the values. So let me just copy paste the values from here. Okay. Right, so here we have been given the value of C dash as 25 kPa. Then we have been given as the value of phi dash, so let's write phi dash is given as 20 degrees. Let's convert it to radian so that there is no problem later on. Multiply pi divided by 180, so it's in radian now. And then we have the value of sigma minus UA, I'll write, that's given as 100 kPa, and the value of K is 1. So these value we have been provided, and then we can calculate the value of tau f. How we can do this, as tau f is equal to C dash, let's put F4, plus sigma minus UA, that is given as 100, okay, multiply tan phi dash in radian, so this one, then close this bracket, and then put plus again, this will be UA minus UW, so UA minus UW is matrix suction, that will be this point 2.5, okay, and then we'll multiply it with theta to the power k. The value of theta is provided here, so we'll just put a bracket here, then we'll put the value of theta to the power, the value of k is here, so let's block it, and finally we'll multiply it with tan phi dash, tan again the phi dash is here, lock this one too, and we are done. So here we obtained 62 point something. Then going down, we can obtain all the values of tau f. So if we see here the value of tau f, we can plot against matrix suction. select data. Okay, cancel. Let's delete this one. Plot tau wave for matrix section. Insert plot. Okay, this plot. Okay, so I think there is some problem. Let's cross check this one. Okay, so values are not plotted correct. We have not written all the values correctly in the plot, so let's shift this one upwards, this one up. Now it should be fine. Okay, so now it looks fine. So if we'll see here, if we observe the value of tau f, which is plotted on the y-axis, and matrix section, which is on the x-axis, then we'll see that the value of tau f is first increasing, then it is becoming almost constant at higher matrix section values. Okay, so we'll see here. Let's jump back to our slide. So this type of observation is obtained that the tau f value will first increase and it will almost become constant at higher matrix section values, right? So if we see here, as we have seen that if we compare the Fredholm formula and this formula, then we'll obtain this tan phi b is nothing but equal to theta to the power k tan phi dash, right? And this will be equal to, if we compare with the bishops, then it will be equal to xi f is equal to theta to the power k. So now let's take a break of 5 to 10 minutes, then we'll continue further from this point. So here we were coming to a point of suction stress characteristic curve, SSCC. So here, as we have seen, that sigma dash is nothing but sigma minus UW, and then there are other researchers who have said that sigma dash is equal to sigma minus UW, and after that some attractive forces and the repulsive forces also comes into picture. These forces are actually because of this in mostly clay soil, in diffuse double layer phenomena, and etc. Then in the unsaturated soil, UA also comes into picture. Okay, and here one of the thing to note, most of the things you have studied in the theoretical class, so I'll just go fast over these things. And then if you'll see, based on the permittivity value, we'll obtain that the value of the tau f against sigma. If you'll plot, then if the pore fluid is water, then this intercept is smaller. As the pore fluid changes and the permittivity value increases, this intercept also increases. Okay. So suction stresses, if you'll see, these are of three types. First two are active stresses, which basically comes into picture even when the external load is not applied, and the third one is passive stress. Okay, so the active stresses are forces due to gravity. Then the type 2 are physiochemical forces, capillary forces, van der Waals forces, diffuse double layer repulsion, etc. Cementation, negative pore water pressure, and these are shown in the diagram here. So moving further, if we will see that suction stresses, cementation, van der Waals, electrostatic repulsion, attractive double layer, and capillary and bond and steric forces are there. And the interparticle stresses, if we plot against the particle size, we'll see that cementation does not depend on the particle size, but as the particle size increases, the capillary action decreases. We have seen, because the size of the capillary also increases. Okay, and then van der Waals forces also, as the size of the particle increases, it decreases. Okay, similar is the concept for double layer, diffuse double layer repulsion. Okay, and against the saturation value, if we'll plot, then we'll see that the cementation does not depend on the saturation, it will be constant throughout, and the diffuse double layer will increase as the saturation will increase, and the van der Waals forces will decrease as the saturation will increase, because the distance between the particle will increase. And then some of the forces are there, such as the capillary forces. First they will increase, then it will decrease, right? So here we'll see that the expression of sigma dash is derived as sigma minus UA plus zeta times UA minus UW, which we have already seen. Apart from that, there are some stresses, that is these physiochemical stresses and the capillary forces. And then the suction stresses comes under physiochemical stresses only. So here we can divide SWCC in 4 zones. Number 1 is before the air entry values, and there is a zone 2 where this transition will take place. Then zone 3 and zone 4 where the residual zone, we can say. Okay, so based on this SWCC curve, SSCC curve is plotted here, suction stress characteristic curve. For the clay soil it will go like this, and for the sands it will drop like this. Moving further, we will see the use of these concepts while solving a problem. So let's get into the problem and solve this to understand better this concept. Okay, so in this problem there are several number of tests which are conducted and the value of matrix suction is provided here. Apart from that, the value of P is also provided, and the value of Q is provided, that is the mean effective stress and the deviatoric stress. And then we need to calculate the value of first we'll calculate the value of sigma S. Okay, and then we'll calculate the value of P dash, that is the effective mean stress, effective mean stress. Okay, so for calculating that, if you'll see, first we will plot Q versus P, and if we see here, then in this plot, if you see, this is the phi dash value, and this intercept is nothing but c dash upon tan phi, if you see, or c dash cot phi. Okay, and this intercept c1 dash, let's say c2 dash upon tan phi. So phi dash will remain constant for all the lines, only the intercept will change, right? So we can determine the value of for these four tests, all tests the matrix suction is same. Okay, so let's see how we can solve this equation. First we will take any two tests in the first subgroup for the matrix suction 0, let's say test 1 and 2. Then we'll write the equation based on the equation that we have studied there, as Q is equal to C dash plus P tan phi dash. Alright, so using this equation we can write Q is nothing but 120 is equal to C dash plus 130 tan phi dash. Then the second equation will be 274 is equal to C dash plus 350 tan phi dash. Now we'll solve both the equations to determine the value of phi dash. So tan phi dash will be nothing but 274 minus 120 upon 350 minus 130. So from here we will obtain the value of phi dash as tan inverse 274 minus 120 divided by 350 minus 130. So it will be equal to 34.99 degrees, or we can say 35 degrees. Then after determining the value of phi dash, we can calculate the value of C dash. The value of C dash will be equal to, if we plot from the first equation, 120 minus 130 times tan of 35 degrees. So it will be around 29 kPa. Right. So the value of sigma S is nothing but this Ci dash upon tan phi dash. So we'll determine 29 upon tan 35. So it will be around 41.4. Similarly, for the second group also we can solve for any test. So as we were solving this for sigma S value, then let's solve it for the test 5 and 6 from the second group of experimentation for different matrix suction value. So let's say test 5 and 6. So we'll write the equation for them also. So the first equation will be 210 is equal to C dash plus P times, that is 150 tan phi dash. Let's call it equation number 3. And the fourth equation will be 363 is equal to c dash plus 370 times tan phi dash. Let's call it equation 4. And if we'll solve them, we'll obtain the value of phi dash as tan inverse 363 minus 210 divided by 370 minus 150. So it will result into tan inverse 363 minus 210 upon 370 minus 150. It equals to a value of 34.81 degrees. So that's again mostly equal to 35 degrees, we can say. So the value of phi dash is not changing, we can say from here. And now if we calculate the value of c dash, then it will be equal to 210 minus 150 times tan of 35, so it will be equal to 104 kPa. So solving it again, we can obtain the value of sigma s, which is nothing but c1 dash mod tan phi dash. So c1 dash is equal to 104 upon tan 35 degrees, so it will be equal to 149.9 kPa, right? Again, for the third set of experiment, we can see that the phi dash is almost will be remaining same. We have seen from theoretical background also, so we can directly calculate the value of c dash. So let me erase this portion so that okay, so that we can get more space. Okay, so phi dash is remaining constant on 35 degrees. So let's call it for test 9 and 10. So if we calculate the value of c1 dash, then it will be equal to 328 minus 185 times tan 35 degrees. So it will equal to 328 minus 185 tan 35 degree. It will result into 198.46 kPa. Okay, so we'll calculate the value of sigma s, and sigma s will be 198.46 divided by tan 35 degrees, which will equal to 283.43 kPa, right? And further, if we move, we can calculate the value of sigma x for next set of experimentation. Let's say for test 13 and 14. So c1 dash will be calculated as 590 minus 238 of tan 35 degrees. So 590 minus 238 times tan of 35 degrees, so it will be equal to 423.35 kPa, and we can write here as 423.35 upon tan 35 degrees. So sigma s will be, the suction stress will be 604 kPa, right? So from here we can calculate the value of P dash. P dash will be nothing but P plus sigma s, the suction stress. Okay, So we can write the value of p dash as 130 plus 41.4, so it will be 171.4. Next 350 plus 41.4, so it will be 391.4, and so on. We can calculate the value of sigma p dash, sorry, the p dash value 736.4. Moving further here, 149.9 plus the value of 150, so it will be 299.9. Moving further, 370 plus 149.9, 519.9, and further if we'll move, 699.5 and 869.5, and so on. We can calculate all these values, right? So in this way we can calculate the value of effective mean stress, and then we can calculate the value of first we can calculate the value of phi dash. Then phi dash will remain same for all set of experimentation. Then from each set of experimentation at different metric section value, we can calculate the value of C1 dash or C dash, and then from there we can calculate the value of the suction stress, which is nothing but C1 dash upon tan phi dash. It is the negative portion of this one, C1 dash upon tan phi dash or C1 dash cot phi dash, right? From this sigma s, we can make use of the formulation sigma dash is equal to sigma t minus ua plus sigma s. So here we can write p dash equal to p plus sigma s. So from this formulation we can calculate all these values. So please have a look how we have solved this one, and do let me know if you have any problems. So the observation which we can make here is that the sigma s value which we are obtaining here If we plot it against the metric suction value u minus uw, then we can obtain from 20 from 200, 400 and 850, and for that we will get different values, and this will, the SWCC will look like that, like this SSCC. Okay. And the Q versus P plot, as we know, that will P dash plot will look like this one, right? So with these examples we can now move on to the assignment questions. So the first question is that the slope on the curve tau f versus u minus cwf over a wide range of clay soil, wide range for clay soil is constant. So under a given net normal stress sigma minus ua and having a value of tan phi b. So if we plot the tau f versus metric suction u minus uw for wide range of suction values for clay soil, so for mostly for clay soil these are at the higher end, okay, and it is written that the slope of this curve is constant. So as we have studied, the slope of this curve is not constant, it varies over this suction range, okay, and so therefore it can be said the phi b value, which is the slope of this curve, it varies. For the initial portion it will be remain equal to phi dash, we can assume, then it will become lesser than the phi dash, so it will vary over the range of the suction. So this statement may not be totally correct. Then we have the second question that says, as the xif decreases, this effective stress parameter decreases, the strength parameters phi b consistently increases with suction. So here we can say that from these two equations, Bishop's and Ferdinand, that the value of tan phi b is actually equal to xif times tan phi dash, and we have also solved a numerical based on this one. Then if we remember from that numericals, we have let's see, where is that numerical? Okay, so I think we have solved it on an Excel sheet, so I'll just open that one, and here's the question, this one. So let me just open the Excel sheet and we'll cross check from there. So if we see here in the sheet 1, then we have seen as the value of suction increases, the value of phi b, phi b also increases, it decreases, right? So it means that but if we'll see the trend of xif and phi b, this xif and phi b, so this trend is actually the same. It means that as the value of xif is decreasing, the value of phi b is also decreasing. So that we can plot, I think, from these two also. Insert, and let's make a plot quickly. So this is the value of xif, and this is the value of phi b, and this is the value of xif. So you see there is a linear correlation. If the value of xif is increasing, the value of phi b is also increasing, right? So here it is written, as xif decreases, the strength parameter consistently increases with suction. So that is not actually correct, okay. So I hope there's no doubt in these two questions. Then in the third question we have the value of phi b is an additional friction angle to capture the contribution of metric suction to shear strength. So the 5V's are actually the additional friction angle that denotes the slope of this curve that is plotted against the shear stress and the metric suction. Okay, so this statement can be considered as true. Moving on to the fourth question, which says that the suction stress is internal stress, state variable, and is independent of applied mechanical loading. Okay, so the suction stress is actually an internal stress variable, and it is written that is it independent of the applied mechanical loading. So we can see that when external mechanical loads are applied to unsaturated soils, changes in the pore pressure and the stress distribution can influence the suction stress. Okay, and the mechanical loading, it can alter the soil structure and it will affect the water retention properties. Therefore, it can be said that this will influence the suction stress. So the mechanical stress will also influence the suction stress. So mostly it is said that the suction stress is primarily governed by the soil water interaction, but it is not entirely independent of applied mechanical loading. Okay, so this statement that suction stress is internal stress variable independent of applied mechanical loading may not be truly correct. Okay, coming to the question number 5, it is written that physiochemical forces are responsible for the change in structure for fine-grained soils such as clay. So the physiochemical forces we have seen here. So these physiochemical forces are basically the short-range forces. So these forces are mostly predominant in clays. Okay, so we can say that in these forces we these are mainly mainly they govern the properties of the clay. Okay, because the particles in the clay are very in the short range. Okay, they are very close to each other. So physiochemical forces are govern various properties of the clay soil, including the plasticity, swelling behavior, and shear strength. Right, so in this way you can answer this question. Then there is a question that as a dried soil mass is wetted with water in unrestrained condition, the van der Waals forces decreases. So mostly the van der Waals forces do not depend on the water content, but as you increase the water content, the particle will move apart. Therefore, the van der Waals forces will decrease. Okay, so van der Waals force basically depend on the how close the particles are. So as you increase the saturation in the soil, the water will infiltrate into the pores, and this will increase the distance between the particles. So this statement is correct in that sense. So in these 6 questions, if you have any doubt, do let me know. So the 7th question says that cementitious forces, which is covalent bond and ionic bonds, and van der Waals forces, they do not depend on the size of the clay particles. So uh, it is true that the cementitious forces, they actually do not depend on the size of the particles. Okay, but van der Waals forces which are there, they basically depend on the size of the particles. Okay, as the for fine grained particle, the van der Waals forces is high. Okay, so this statement is not truly correct that cementitious as well as van der Waals forces do not depend on the size of the clay particle. So van der Waals forces are dependent on the size of the particles, and cementitious forces are independent of the size of the particles.
Moving to the question 8, it said the shear strength parameter of a given soil are to be estimated under three different states: oven dry state and saturated with water and ethanol. Then a direct shear test is performed in three identical specimens with soil which is designated as A, B and C. The shearing on specimen A is performed in overdried condition. Okay, so A is the one which is having overdry condition, so air is the pore fluid. Okay, whereas specimen B and C are saturated with water and ethanol, so respectively. So B is the one which is saturated with water, so B is the one which is saturated with water, and C is the one which is saturated with ethanol. Ethanol will lie somewhere here. Okay, so C is the one which is saturated with ethanol. Under such condition, the cohesion intercept obtained from the tau versus sigma plot. So this is the tau versus sigma plot, and this is the cohesion intercept which we see here. For specimen B is less than both specimen A and C. So as we'll see here, for specimen A the cohesion intercept is this much, right? And for specimen B and C, for A, so for specimen B the cohesion intercept is this. For specimen A and C the cohesion intercept are much higher, right? So this statement is actually correct, that the for specimen B is the cohesion intercept is lesser than the specimen A and C, right? So in this question, if you have any doubt, do let me know. Then we have this question number 9, that in unsaturated soils the pore water pressure acts isotropically in all directions in a uniform manner. So the in unsaturated soil, due to the surface tension which is present, this pore water pressure is not isotropic, so it does not act isotropically in all direction in a uniform manner, right? So in this way you can answer this question. Then we have the last question of the assignment, that says, in a suction control axial test under the same applied net normal stress condition, which of the following is true? The shear strength of unsaturated soil is more than the shear strength of saturated soil. The shear strength is maximum at lowest metric suction, and the dry soil has maximum shear strength, or all of the above. So as we know, the shear strength is not always maximum as lowest metric suction. Okay, it varies with different soil types, stress conditions, as well as the moisture contents. So in some cases the shear strength may increase with increasing metric suction up to a certain point, right? After that beyond it may start decreasing, right? So after that it may start decreasing due to excessive desaturation of the soil. Then so this option will not be correct, right? And then there is a third option: the dry soil does not always have the maximum. uh, it is written dry soil has the maximum shear strength, so it is not true that they do not always have the maximum shear strength. While shear strength tends to decrease with decreasing moisture content, but up to a certain point. After excessive dry soil, they may become brittle and leading to reduction in the shear strength, right? So this option is also not correct, and so you can say the first option is correct, that is the shear strength of unsaturated soil is more than the shear strength of the saturated soil. This is mostly due to phenomenon that in the unsaturated soil there's another type of force, which is the metric suction, UA minus UW, because of which the strength increases, right? So these are all the questions. If you have any doubts based on these questions, please do let me know. Okay, so if you may have any questions later on, please feel free to drop me an email or ask me in the next class. So thank you. I'll close this meeting. Thank you very much for joining.